All right, so let's start this. Oh yeah, already recording. And I want to share a screen. All right, so today what I'm going to do is I'm going to go through some very simple electronics stuff. And then I'm going to actually switch over to some of the spectrum training because they did a good job with it, and why reinvent the wheel. I just have a couple of things that I'm going to cover before I jump into the electronics training that Spectrum has. So I want to make sure that today what I'm trying to do is I want to introduce some common terms that we use for our electrical subteam and a brief introduction to some of the core components of an FRC robot. And yeah, so just to start with, some three major terms that you're going to hear a lot when it comes to the electrical world are voltage, current, and resistance. And so voltage is measured in volts, and it's a potential energy available. So when you have a AA battery or a D battery or our FRC battery, all of those have some amount of volts available for it. And whether it's a 12 volt FRC battery, or if it's 12 volt or 12 volt drill battery, those 12 volts are the same. It's the potential energy available, the difference in voltage. I don't know. It's a measure of how much potential energy there is. And so if we were to think of it in terms of water, water is often used as an analogy for the electrons moving. And so the voltage is how much water pressure you have. So if you imagine in this picture here, the more water you have, the more water pushing down that's trying to push it out. So again, 12 volts is going to be 12 volts, even if the two battery sizes are very different. The difference might be how long it can provide 12 volts for, or how quickly it can handle some of the discharge and lots of other little details. But 12 volts is generally 12 volts. And then current is a measure of how much electricity is being moved. You'll hear it referred to as amps or amperage. Oftentimes we'll also worry about milliamps. You guys are familiar with a SI system for milli and micro and all that. So milliamps are definitely something that you'll hear about often. And so if we go back to our water example, that's the flow rate of it. And so how fast that water is moving. And so for current and electrical systems, it's how fast the electrons are moving. And then lastly, we have resistance, which is measured in ohms. Similar to how we'll have amps and milliamps, sometimes we'll come across ohms and kilo ohms or mega ohms, things like that. And that's basically the amount of opposition to current flow. So if we think about our water example again, if it's a smaller pipe, if the diameter of the pipe's smaller, it will have more resistance. And so if we look at this middle one here, even though both of these have the same voltage potential, the water level is still the same. This one with the bigger pipe is going to allow water to flow much faster through it than this one. The smaller one, even if the water might seem like you have more pressure here, right, you're going to get less water total out of it. And so you'll hear about Ohm's law, or you'll hear about this VIR triangle. And so if you remember this triangle with V over IR, you'll know that if you're trying to calculate voltage, it's current times resistance. If you're trying to find your current, which is I, it's voltage over voltage divided by resistance. And if you're trying to find your resistance, it's voltage divided by current. So changing one of them affects the other. So when we talk about our FRC batteries, and we talk about wanting to minimize how much wire there is between the battery and the power distribution panel, and trying to increase the size of the wire of it, we're basically trying to reduce the resistance so that when we do the 12 volts divided by our smaller resistance, we have more current available to our robot. And so obviously we don't usually have to worry about voltage and current and resistance too much, especially resistance. The only time we worry about resistance is really the amount of resistance between the battery and the power distribution panel. Voltage, you'll worry about that occasionally because we want to make sure our batteries don't get down below a certain voltage, either while we're driving or while it's sitting there. Once it gets below a certain point, we say we need to get that battery charging again. And the programming team may worry about current because we might current limit things to make sure that a particular subsystem or motor isn't drawing too much current. Some other terms that we'll talk about a little bit when we do more electrical stuff. So we have stranded wire and solid wire. So we've got a picture of that up here. So stranded wire is what it sounds like. It's one wire, but it's a bunch of little wires all together. So you can see it's stranded. You can separate that out. And then there's solid core wire, which is just one piece of copper surrounded by the insulation. The stranded wire is a lot more flexible. And so we generally almost always use stranded wire. I can't think of really any instance where we've used solid wire anytime in a while. So almost all the wire that we have is going to be stranded. It's more flexible, so it's good for us. Another term that you'll hear when we're doing electrical work is crimp, or we'll crimp connectors. And so you can see you have a tool here, and basically you're compressing a terminal around a wire. And so you can see this metal, it was a ring, and then this tool crimps it and basically clamps it shut so that metal is pressed up against the wire. And that way the electrical connection goes from the wire to, in this case, this ring terminal that you can see here. So you can use that to transfer electrical power from one place to another. Another term that you'll hear is solder. So it's spelled with an L, but it's pronounced solder. And so that's when you melt a metal that joins two different wires or terminals together. So there's a picture of it here. You have something called a soldering iron. This gets really, really hot, and a type of hot that would burn your fingers. So you want to be careful when you're doing that. And basically you heat up the wires, and then there's solder is a type of metal. It's an alloy that once it gets to the 600 degrees or whatever that it is here, it melts. And then when the iron's away from it, it cools down, and then you've got a bonded wire here. And another thing you'll obviously hear about is stripping wire. And so that's when you're removing the insulation from a wire. So there's usually a PVC insulator around the copper. And so when you strip it, you're basically cutting that insulation and pulling it away. This is one of the simpler types of wire strippers. We have some other kinds. So any questions about those terms? We're not going to talk a lot about those terms today, but I figured that it would be good to introduce those terms if we're going to talk about electrical work.
Is stripping a wire dangerous?
No. The only thing that's dangerous about it is you should, of course, still be wearing your safety glasses, especially when we do this stranded wire here. Sometimes you'll clip a little piece of stranded wire, and that wire can kind of go flying. If you don't have your safety glasses, you could get it in your eye. And so just generally a lot of electrical work, even though you think, it's not a big, powerful robot, it's not particularly dangerous. You should definitely be wearing your safety glasses when you're doing most all of your electrical work, because it's easy to accidentally snip something and it goes flying. And we just don't want anything to hit your eyes, obviously. Okay, so I'm going to use Spectrum's stuff here, because as I said, they've got good stuff. And why reinvent the wheel here. So I'm going to skip over some of their slides. Oh, I do want to point out too, I did steal, the Spectrum has this YouTube video that they found, and I watched a little bit of it, and it's pretty good. It goes into the water analogy more detail. So I'll have these slides up on our training page, and you can click that link if you want to watch it. It's about a 10-minute video. Okay, so I'm going to talk specifically about the electronics of an FRC robot. And so what is it that they do? It powers the robot. So you think about the battery, and then all the control system stuff is what distributes the power to the motors on the robot. And then it also communicates with the driver station. So it receives the instructions from the driver and tells them to the Robo Rio. And then the Robo Rio goes and figures out and sends to the motor controllers what else to do. And then it collects and uses any of the information it gets from the sensors. So the Robo Rio, again, it's the processor, computer, the brain, whatever it is that you want to call it, that's part of the control system. So it's receiving that information and then sending instructions out to the motor controllers about what to do with that. So this is a simplified diagram. And so these are the control systems that we may or may not use next year. So there's typically, for the past 5-6 years, there's only been one control system allowed. This year, they're in between control systems, so you can use the older one or you can use the new one. This was put together mostly with the old stuff, but there's a slide or two at the end that we'll talk about. So you start with your battery. There's a big 12-volt battery, And this is an Anderson battery connector. Specifically, it's called an SB50. And so that's a big, hefty red connector. And that's what you connect your battery to. And so you can see what happens is that the black, which is the negative side of the battery, goes directly from the battery through the Anderson connector and to the power distribution panel. The other side is the positive terminal of the battery. And so you want to make sure that red is going to the plus side and black is going to the negative side of the connector. And then the positive side actually goes to this main breaker before it goes to the PDP. And so the reason for that is that this main breaker, when it's off, it basically disconnects the red wire. And then when it's on, it connects it. So this is a switch that basically either allows the power to flow from this end of the red wire to this end of the red wire and all the way to the PDP or not. So that's why it's called the main breaker or the on-off switch. And so let me go through a little bit more on the next slide here. So you can see there's only one battery. It's 12 volts. It weighs about 14 pounds. It's not part of our normal weight limit. They've removed the battery from being counted against your weight. So when our robot has to weigh 125 pounds, you also have to add in the weight for the bumpers and the battery that aren't included in our official robot weight. And then there's the PDP here. So the PDP stands for the power distribution panel. And basically you can see that there's a red and black pair all along the way here. And so this is one pair of red and black wires would go to motor controllers. And so this splits out all the power to all the other things on the robot, motor controllers, the limelight camera, everything else. And in fact, you can see there's tiny red and black ones down here, and that goes to the Robo Rio and the radio and some of the other control stuff. And so the PDP is obviously very important to getting the power to everything else on the robot. The batteries are all the same, but you might notice some slight differences in them. They should be charged pretty much after every use. The cells in them are somewhat fragile, so you don't want to drop them. You don't want to grab, when you pick it up, don't grab it by the wires. You want to make sure to grab it by the case. If you pick up some batteries and you notice that the wire is loose around the terminal, that's not good. You want to make sure that's a good strong connection there, because basically if it doesn't move, then you have a low resistance. If it moves a lot, then you have a high resistance between the two terminals, and so you can't get as much current flow out of it. So yeah, we want to take good care of our batteries. They are a potential fire hazard. Once every couple of years, you'll hear about a battery fire or like a robot that catches fire. Elijah, I see you've got your hand raised. Do you have a question?
I didn't mean to do that. It was an accident.
No problem. Let me lower hand real quick. Okay. Yeah, so batteries. And then so you can see this is the SB50 Anderson connector. And there are some different types. We also use the SB50 connectors. There is a slightly larger type that you can use. So the SB50 is intended for something called 6-gauge wire. I talked about how the wire has resistance. So the more wire you use, the more resistance you have, but also the thinner wire you use, the more resistance you have. So it might seem kind of backwards, but the smaller the gauge, the larger the wire. So a 4-gauge wire is larger than a 6-gauge wire, which is larger than a 10-gauge wire, etc. And so we either want to use 6 or 4-gauge wire for our batteries. We can ignore that slide. This is an up-close picture of the main breaker. It might be a little bit hard to tell, but there's a red button here, and that's the off switch. So if you need to turn off the robot, you want to push that red button down. And then you definitely can't tell it here, but there's a black lever here. And so to turn the robot on, this, let me see if I can annotate. Yeah. So normally when the robot is off, you'll see that the lever kind of comes out at about this angle here. And then you want to push this lever in that way. And so once you do that, that's what turns on the robot. And then when you push that red button, that pushes the lever back out and breaks it up. Oops. And okay. So there are times that the main breaker will automatically turn off the robot. If the robot is drawing too much current, then the main breaker, basically there's an element inside that if it gets too hot, it causes the breaker to turn off. And so you can see here it's a 120 amp breaker. That doesn't mean as soon as you hit 120 amps that it turns off. There's a time association with it too. So either the more current in a smaller period of time, or if it holds 120 amps for an extended period of time, that's going to turn off the robot. And it does it to prevent fire or other damage. Again, this is the older power distribution panel. There's individual port. You can see in this particular picture, there's no breakers in between here versus up above. There's a representation. You can see there's this black breaker here that says 40, 40, 40, and then there's ones here that say 30. And so those breakers are how much current you allow to go through each of these ports before the PDP or before that breaker trips, and then that port no longer has voltage on it. And so you can do that individually to protect parts of the robot. So say, for instance, that we have a motor that would burn up if it used more than 30 amps or something, or more than 20 amps. We could put a 20 amp breaker and prevent it from a hardware perspective from pulling more than that. Now, granted, what happens if that occurs is that the motor turns off. So you want to do other things to prevent that from happening first. But it's kind of like a last resort safety measure there. This also, the PDP, we'll talk about what the CAN bus means later, but the CAN bus usually terminates at the PDP. And what that means is it's just the last one in a chain. So the CAN device goes to a bunch of different motor controllers, and it goes from one to the other. And then the last thing it goes to is the PDP. And there's a little switch here to make sure that you're indicating that you want the PDP to be the terminating device of the CAN bus. So we'll talk about that more in a little bit. All right, so some other key parts of the electrical system, of course, the Robo Rio and the radio. So the Robo Rio is the computer, basically. It's the brain of the robot. This is where we put our program on it. And this is also what sends out the instructions to everything else on the robot. And it's connected via an Ethernet cable to the radio. And so the radio connects via Wi-Fi to our driver station. And so our driver station sends commands to the radio receives it and sends it back to the Robo Rio. And then there's a bunch of different ways for the Robo Rio to control stuff. Generally speaking, the only thing that we really use is the CAN bus. And so this CAN bus is what we send instructions out over to our motor controllers. You can also receive sensor inputs from the DIO. DIO stands for digital input output. And then there's also an analog in. So we could have a sensor that has an analog input. We could have sensors or things that have digital inputs. You can also control motors individually with PWM outputs. We don't use that as much. I don't like the PWM connectors here. I don't think it's as reliable as using CAN. And then there's some other things that you can use for sensors. We'll use the SPI bus for gyro, which is a type of sensor that's kind of like a compass. There's an I2C and RS-232, which are also sensor ports. So those are methods of communicating to electrical devices. We don't use that too often, and most of the team members don't need to understand exactly how that works. It's basically something we get a sensor, we plug it in that one situation, and then we're good to go. All right, so just another picture of the Robo Rio. You can also see the input for the power is this black connector up here, and it has a very particular port of the PDP that it connects to. You can also connect to the Robo Rio via USB or Ethernet directly to a computer to either drive it or to program it. An up close picture of the radio, nothing too special here. All right, so if we go back to our initial picture, we originally just had the battery to the breaker to the PDP. Now this explains a little bit more of some of the other systems that are going on here. So you can see this red and black wire are the power to the Robo Rio. And you can see it gets power specifically from this far right side on the bottom of the PDP. And there's this little 10 amp fuse down here too. So that's something that we need to make sure is there. So power from the PDP to the radio or the Robo Rio. And then there's this green and yellow wire up here at the CAN bus. This is one method of doing it where the Robo Rio just connects directly to the PDP via CAN bus, and the CAN bus is terminated at the PDP. And then you could using these yellow and green wires, we could via PWM connect those up to motor controllers to control a motor. And you can see that the individual ports from the PDP go to motor controllers. So in this case, there's a 40 amp breaker on this port that goes to a motor controller to a motor, and then a 40 amp breaker on this one that goes to motor controller and motor. And you can see that there's a separate PWM cable for each of them. So any questions about that before I move on? I've done a lot of talking, I know. Okay. So this is just kind of looking at the new stuff here. So the PWM wires are a simple way to control the motor controllers, but it's basically only driving the motor controllers. You're not getting any feedback from any sensors on the motor or anything about the motor controller. And you need a separate PWM wire for each one of the motor controllers, generally speaking. So we don't use the PWM as often. Another way to do it is the CAN bus. So this is just like before, except now the CAN bus goes first to a motor controller. And then you can see you got one pair of green and yellow cables going to the motor controller, and then a green and yellow pair coming out and going to the next motor controller. And then those those CAN bus cables come out and go to the PDP, and it terminates over here. So the CAN bus is what allows the motor controllers to communicate back to the Robo Rio as well. So it allows a lot more smart features. And this is called daisy chaining. When you have, one connector, you have the Robo Rio connected to a motor controller, which is connected to another motor controller, which is connected up to the PDP. That's daisy chaining. So this is how we connect up our motors. There's a bunch of different motor controllers. You'll sometimes see them referred to as speed controllers. We almost always call them motor controllers. The ones that we use most often are going to be the Spark Max. And then we have a ton of Talon and Victor SPXs, but we are getting to a point where we're only going to really hopefully use brushless motors. And so we'll use Spark Maxes for the Neos, and then the Falcon motors, which is a different type of brushless motor, already have a motor controller built into it. So we probably won't be using the Talons and Victor SPXs as often on our robots. Just like Spectrum, we only use CAN on our competition robots, and I've kind of talked about that already. So the driver station, what that is the laptop and any game pads or controllers or anything that buttons, switches, etc., that we use to control the robot. And you can see here the electronics installed on Spectrum's robot. So the Robo Rio is here. You can see the green and yellow CAN wires. You can see the battery connector. There's a rectangle here where the battery would go in, and that purple strap would strap it down. Plug into this red connector here. You can see the main breaker up here. I imagine it looks like their power distribution panel is beneath their Robo Rio. And you can see the power cables coming up here to a motor. You can see the CAN cables going to the different motor controllers up here, all that kind of stuff. So something I am kind of excited about are some of the new control systems. I have pre-ordered 2 sets of them, and so I hope to use them next year for our competition robot. Some of the big changes are that this PDP, or this is now called the Power Distribution Hub, the PDH. And so these use levers instead. So if we go back to, let's see, let me get a real picture here. So if we go back to here, basically you have to insert a tool that's kind of like a screwdriver, and it opens up the inside of here for you to put a wire into. But with a new one, you lift up the lever, put your wire in, and then you put the lever down, and then that clamps it in place. So I'm excited about that easier access. They've also managed to make it so that all of these could be 40 amp breakers if you wanted to, and made it so that there's 20 ports. Before we only had 16. So a lot of changes with the power distribution hub. There's also a battery voltage display right here on the main thing too. Lots of little changes that I think are all pretty neat and exciting. The radio power module is also exciting to me because this should hopefully make power to the radio a lot more reliable. Basically what happens is that you have 12 volts go in here, and then when you connect up your Ethernet cable to the radio, power goes out over the Ethernet cable to the radio as well. And so you get power over that Ethernet connector, which is a lot more stable than the barrel connector. So we can go to the Rev Robotics page and look a little bit more at some of these things. I think I've kind of covered what I would want to talk about with it, but I think this will be a good change for us, and I'm looking forward to it. So there's also going to be a Robo Rio 2.0. So I'm not too concerned with that. It's not going to be major changes like some of the other control systems, but we will be getting a couple of them just because we don't have a ton of the older Robo Rios, and we need a couple more for our robots. And so something that we will need to just keep in mind is, if we're using a Robo Rio 2.0 versus the original Robo Rio, we want to make sure we don't accidentally get those mixed up. Yeah, so any questions about anything? I kind of went through a lot of material pretty quickly because it's only about 30 minutes in. But I don't know if you guys would want me to keep talking even more, or if this is kind of a good stopping place.
I do have a question about the difference between the Robo Rios and stuff.
Okay.
So what's the difference between the Robo Rios?
There's not too much significant. Let me see if I can pull up the page just so you can even see how similar they are. Okay, so let me share screen again. All right, so this is the Robo Rio 2.0. And you guys just saw the old one. Let's see, let's go back here. Okay, so do you guys see, this is the original Robo Rio here. So you can see it's got this lab view image on it. And here's the new Robo Rio where it has just the NI logo on it, right?
Oh, different manufacturer.
So they're very, very similar. Some of the key differences are that we're going to have to provide an SD card for the memory. So you can see there's this micro SD card that gets put in the slots here. So that is one key difference. I'm not particularly thrilled about that, honestly. I would rather have the memory be internal, but that was a decision made by NI for valid reasons. It's something they didn't do it for just because. They did it because they think that it will provide a better experience. I'm just not as convinced. And then the processor is a little bit faster. There's a little bit more RAM or memory. So there is a blog that discusses some of those differences. Probably something that is a little bit more important is something called Brownout. And we could talk about that because that's electrical stuff. So basically, when we're driving the robot around, as motors and stuff are pulling current, the battery's not a perfect power supply. So as current is being pulled, voltage drops. And so when a lot of current is pulled, the voltage can drop really far. And so when we're driving the robot around normally, we'll see it get down to 6 or 7 volts, even though when it's not moving, it might be like 12.5 volts. And so as we're driving and it gets down lower and lower, at some point there's not enough voltage, and the Robo Rio would basically turn off motors or turn off the battery or the radio, things like that. And so one of the changes to the Robo Rio 2.0 is that the brownout voltage set point can be configurable. We probably shouldn't be messing with that unless we have a really, really good reason. But that is a change there as well.
So brownout is basically a manual switch to mess with the, if I'm not wrong, the voltage usage, right?
Yeah, so that is one thing, is that you could manually change something about the brownout levels. Any other questions? Was this useful? Did I cover here? I'll stop recording so that you guys